In this problem, this is where I'm starting, and this is what I'm trying to figure out. So moles of H, that's what I want to know. And I'm starting with this large number of molecules, and it's CH4. Now, check something out here. Up until this point, we've had the same thing, but these are not the same. So I've got an extra step in here where I'm going to have to change from moles of this one into moles of this one. So that's what's coming. Don't forget, with molecules, it's the same as atoms. It's the Avogadro's number. It goes with the molecules term. And then it's still just equal to 1 mole. So again, though, this is CH4 and CH4. I'm not changing to something else until I get to moles. So drop this unit down. Molecules of CH4. And you cannot go a lot of places from molecules. You really need to get them into moles. Then you can do other things. Then drop this unit down again. Moles of CH4. Now this is the place where I could go to grams, but it's not asking for grams. I could also go to, again, if I had density information, I could maybe go to liters. It's not asking me to go there either. It wants me to go to moles of H. So you can also go from moles of something to moles of something else. That's what we want to do, moles of H. I'm going to go back a step. In 1 mole, this is the Avogadro's number, 6.022 times 10 to the 23rd. Remember the moles, like it's almost always 1 or like small numbers, like 2 or 3. You're not going to have numbers that are as big as Avogadro when you're dealing with moles. Now, in this problem, the trick is that you assume there's just one of these big guys. So CH4 is larger than the C. And then you look at the subscript, and that tells you how many H's are in there. So there's 4 H's. If you were curious, this is what this looks like. You'll learn about this coming up also. But you can see that there's a total of 1, 2, 3, 4 H's in one of these. Now, if you had a ton of them, the relationship would still be 1 to 4. Copy, paste. So like there's one there, and like here's another one here. So in this case, I would be like there's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. 12 hydrogens to a total of 3 CH4s. Notice that relationship is still 4 to 1. So let's just make the numbers easy for us. Don't use these numbers. There's too many numbers to put in. You don't want to have to put in 12 and 3 and put all that in your calculator. So just assume one of them, because it's the same relationship whether you have one or tons of them. And you learn that from the law of multiple proportions. So it's the same ratio, whether you have a tiny sample or a huge sample, it's still the same ratio. So all we need to do now is just stick this in our calculator, and then we will be able to solve the problem. Again, I'm not expecting a number that's like huge, like an Avogadro number. So keep that in mind too. So I have, oops, I can't see my number. 7.5, notice that has 2 sig figs. I'm going to use my E key to the 30th. And then I like going across the top and then dividing on the bottom. Sometimes I don't follow that trend, but when I skip that, I end up leaving out a number. So I recommend trying to be consistent, whatever you decide to do. So I'm multiplying, and then I'm going back, and I'm dividing by what's on bottom. 0.6022 e to the 23rd. So the total number that I get here, it's 498173336. You're like, what did you say about the large numbers? Well, that's still nowhere near as large as the numbers we started with. And if I'm going to round that with the correct number of sig figs, 1, 2, the 5 is the second one, sig fig. Then 1, 2 sig figs. Notice that the 8 is going to round this up. So here's where you're like, oh, that's crazy time. All right, so for my 8 to round that up, I still have all the zeros in it. 0, 0, 0, 0, 0, 0. So I've also got the zeros in it. But look, I've got to, I can't, this only has 1 sig fig. So see how that only has 1? I've got to throw a decimal in to make it work. Now, if I put a decimal here, that will mean that I rounded the equivalent of 50 million to just 50. I can't put a decimal there. We use scientific notation to solve the issue. So I'm going to say that this becomes 5.0 times 10 to the 1, 2, 3, 4, 5, 6, 7, 7th. And again, my units, the molecules canceled out and the moles canceled out, and I was left with moles of hydrogen.